Last time we were basically doing I told you about resultant moment. That's good. So we're gonna go forward from that. So the next we're gonna do a definition of two things that you're more interested in knowing, and that would be the center of gravity and the center of mass. So center of gravity is basically known as a point where all the weight of the object appears to act. This word that I've just written, this is basically the keyword that we need to see. Do not forget that, it's very important. Finally, then we have center of mass, which is a point where all the mass of an object seems to be concentrated. Remember that center of gravity can be outside the body. It's not important that it always is within the body. It can be outside as well.
सर आपने
Yeah,
ग्रेविटी के लिए आपने कहा है अपीयर्स, जैसे इसका मतलब कि वाकई नहीं होता.
gravity appears. Yeah, it's like
Like it's
it's like that weight is coming from one point altogether. It's कहीं
but
मतलब.
not really, because like it appears.
Like I would say, just say if you sleep on a bed, right? So you're sleeping, but then all your weight is acting on the bed. Do you agree? From
Yes.
different points.
Oh, okay.
But then basically all of it, if you look at it in a big scenario, all of it comes from one single point. Seems like it comes from one single point. Do you get it? Like that.
Yes.
Yes. That's why it's not like always coming from this point, like I told you about the bed example, where then it is just it appears if we hang some mass over something like lamina or something becomes so it will basically it would seem that it's coming from a point. Understood? Like that. So you
Okay.
got to remember this, okay? Now for center of gravity, it is very easy to find when it comes when it comes to regular shapes. For instance, regular shapes like a square, maybe a rectangle, a triangle, circle, they're all basically regular shapes like this. So in case of regular shape, you can just simply draw a line of symmetry. Line of symmetry is a line that basically cuts any shape into two equal halves. And wherever the two line of symmetries meet, that would be the center of gravity, which means from that point, all the weight is acting. Seems like it. Okay. Same goes for this one. You can cut it from here. You can also cut it from here. So where it meets, that would be center of gravity. Means all the weight is down from here. Then for triangle, you can go through vertices. So this would be the center of gravity. And then for circle, you can go through the diameters from anywhere actually, and wherever they meet, that would be the center of gravity. All right, everyone. If you have any questions, you can ask. Then you should also remember that if you guys can draw this actually, I want to go down. Yeah. Okay. Now let's talk about irregular shapes. You already have done this in IG, I believe, but I just want to remind you for irregular shapes, we have we have to basically place it on a sort of a suppose the shape looks like this. So we put it against a stand, and what do we do is we pin it from one point, and you might remember that we draw lines and stuff like that. But that's not important. But what you need to remember is that this is the line of action of the pivot, and if you basically apply a force onto this from some side, so it means the moment would be this force times this perpendicular distance. That's causing it to move. Okay. It could have a center of gravity everywhere, and the reason why there would be a center of gravity when you leave it, when you leave this force, so wherever the center of gravity is, so in fact, I will make this again. Wait. Okay. So if I stop applying this force, so what happens is that this object, if let's suppose its center of gravity was somewhere here, maybe here. So the weight is acting this way, and because weight is acting this way, the distance perpendicular from the pivot is d. That is why it is going to come and rest at the normal location like this. Do you guys get it? So it'll come back to its equilibrium position because of the center of gravity, not aligned with the pivot. Okay. Shazib, did you overslept? Did you forget about the class? Now, why this is so important, the concept of center of gravity, I'm going to explain this using an example so that you guys know what we're really looking at. So suppose you have this high desk or something, or a platform sort of platform, and on the top of the platform there is an object which is right here like that. Okay. So they say that this platform from here to here is 10 meters high, and the box is of a uniform shape, which is basically 2 meters from here and about 4 meters from here. So what happens then is that this box falls like topples, and it falls on this face, other one, like that. And again, the same thing. This face is obviously 2 meters, and that is the 4 meters. Now, so the question says that a uniform density rectangular block falls from height of 3 meters onto the floor. On the other face, as shown. Okay. Now, it says what is the height of center of gravity after falling? First, this is the question. Then, in the next one, it says calculate the loss of gravitational potential energy if weight of block is 500 newtons. Okay, so this is the question. So please read it and let me know what is the answer for the first part and second part. Anybody can tell me what would be the answer for the first part?
Uh, 12, the height will be 12 meter. Not 12, sorry. 7, 7 meter.
12. Height will be 12. No, 7 meters. 7 meters now. Okay. But I'm not asking about that. I'm
Mhm.
asking about, he's asking what is the height of center of gravity after falling?
Is it 1 meter?
Yes, that is correct. Because you guys see that this, if I make two line symmetries, right? Initially, the height was basically in the middle. It should be here. The weight must be acting. So that should be 2 meters. You guys agree? Now, when it flips, the new height has changed. Like now, the center of gravity is right here. So it is only 1 meter. Do you understand, Mohit? Shazib, Zirwa, any questions here? Now they want us to find the gravitational potential. I'm just going to give you the formula because we have not done that. So gravitational potential energy is mgh. Now I can say mg is 500. What is the height? Who can tell me the height? Fallen.
14.
Yes, Abdullah, Asma, anyone? Who can tell me the height? 14. 14 is the height? No, that's incorrect. Yes, Shazib. Shazib, wake up, please. Yes. Abdullah, 7. No, Abdullah, that is incorrect. 7 is not the height. Afan, Zirwa,
One.
Fatima.
Is the height one?
1. No. So now, let me tell you people this. The problem
It's
is,
12. I said it's 12, right?
no, what you guys need to remember is that when it was falling, you guys need to understand that the height at the center of gravity was this much, right here. Now the height is this much. Basically, where the weight is acting, the real height that it has fallen is from here to here. Do you guys get it? So it means that this is the height we're looking at. What is this height? This height would be basically 12 from this minus 1. So it should be 11 meters. Do you guys get it? So basically what I've done is this from here till the old center of gravity was 12, and now the new center of gravity is at 1. So I'm going to subtract 12 by 1, so I'm going to get 11. So what you guys need to remember is that the height now on, just remember, and you don't, basically this questions were simpler in IT, so you didn't have to do this, but height is always taken from center of gravity to new center of gravity. Anybody who did not understand this, please let me know. Now, just simply add the things. So mg is 500, height is 11, so this is going to be 5500 joules. Is it clear, everyone? Let me know if you have a question. Okay. Now, the next thing. So you please write this down. Okay, good. Good. Wait. I need to. Okay. Now the next question, which is related to this. So, okay. So next. So now, then you have to look at the toppling point. Now, toppling point is another important, factor that we need to look at when you're judging with center of gravity. For example, if there is an object. Oh wait, this is not good. I don't have space. Wait, I gotta go to the next page. Now, so what I'm saying is, suppose we have a point like the object like this. Okay, obviously it will have center of gravity somewhere in the middle, and right now this center of gravity basically is passing through this dimension. Let's call this dimension A. Let's call this B, C, and D. All right. What toppling point means is that if you apply a force on it, so if you apply a force on it, I think this is not exactly accurate. So let me just draw a bigger one. Okay, that's better. So if you apply a force and you bring it to this position, like you're applying a force right here, you bring it to this position. Now the center of gravity is going to pass through this point, which is the edge between A and B. So what happens is that you do not need to do any work after that. The object is going to fall or topple on the side B. This is what toppling means. Okay. So it's going to automatically just fall on the other space. Now, why is this so important? Because this point basically sort of changes the center of gravity. So let's have a look. So let me just put it here. This would be the toppling point. So, right, work to bring an object to the toppling point. Now let's see. So assume that we have an object given like this, which has certain dimensions again. So it says 2 meters from here. I may not be very accurate with the drawings. This is 4 meters. And now we have brought it to it's not good. Not something I want. So we brought it to this point where now it's gonna topple, right? So please understand this. This side, if you try to topple this side, would be 2 meters. This is the toppling point. Is going to be 4 meters like this. In reality, the center of gravity initially was right here, obviously. So the center of gravity from the height perspective is just 2 meters from here. All right. If you draw a straight line like that, so it's gonna basically the center of gravity will be somewhere here. And because you're changing the direction, it means that because this side is also 2 meters, this will be 90 degrees. This becomes a triangle, as you can see. Now, I want to find what the height, what is the other length of the triangle. So I can simply use, let's call this whole length from point to this point as y. So which means that y will be equal to 4 square plus 2 square under root, because I got to take the Pythagoras theorem to find the hypotenuse, and y will come out as 4.472 meters. Do you guys understand? So if I want to basically I want to find this height, which is the height of the center of gravity. So the height will be basically y by 2, because y is the total length. So it's going to be 4.472 divided by 2. So the new height of the center of gravity is 2.24 meters. So by applying a force on it, what we have done is we have raised the height of the center of gravity by this amount so that the rest of it can fall itself. So which means that now from before, the change in height is going to be 2.24 minus 2, so it's going to be 0.24. And the work done to do that would have been force times displacement. If let's suppose this was 500 newtons, so the total work done that is needed to be done would be 500 into 0.24, which is 120 joules, and after that it is going to fall itself or topple on the other side. Is it clear, everyone? So the basic idea of how we're finding work done or anything is that you always basically subtract the height of previous center of gravity to the new one, and that's how you can find the change in height. Do you guys understand what I've done here? Any questions? Let me know, please. Now, okay, Asma, do you understand everything? Any questions you have? Okay, Caroline, Abdullah, Imal, Mohit, Fatma, Farina. Yes, Asma.
Yes, sir.
Okay. Yes, Asma, what's your question? Upper the resultant moment thing, I don't get it. Asma, this one, the last time what we've done here? Okay, Asma. Asma, basically, in this question, we had to find different moments, right? So let me explain this again to you people, okay? Why it is important. You see, this is the line of action of the pivot, which means if a pivot is here, it's like here. So what you guys need to remember is that if there's an 8 Newton force, the force must be perpendicular to the pivot or the line of action of pivot to basically have an effect on the moment. Like for example, if you look at 8, the 8 is acting here and it has a perpendicular distance of 20. Like from here till here, the distance is 20 and this is 90 degrees. Do you understand? Now forget about everything else. Imagine this. If you apply a force on this, forget about the other forces. Don't you think so that this force is trying to turn the whole thing like that? Yes, Usman, do you agree? What is this direction? This is basically anti-clockwise because it's going in this direction. Understood? Now think about this force. Forget about other ones. If 6 Newton is here and you try to pull it, this is the line of action of pivot. From pivot to the force, the distance is 40. But you might notice that the force and the distance are parallel. They're not perpendicular. Isn't it? It means this force will have no moment because moment is only produced when there is perpendicular distance from the force till the pivot. Okay. So this is nothing. This produces a moment. Now let's look at 10. With respect to pivot, pivot is on, this is the line of action pivot, okay? So the force 10 is here, but now from the pivot, you see it has a perpendicular distance till the line of action pivot. So pivot is here, which means this is 15, this is 90 degrees. So now 10 and 15 will cause this object, or trying to make this object go like this. You agree? So this means that it is going to turn it through clockwise. So this produces a clockwise moment in that, basically, of value 10 into 15. Get it? Now look at this force 5. 5 is acting here, and this is the line of action of pivot. So I'm saying from here to here, the 5 force is 90 degrees to 30-meter distance, as you can see, till the pivot, right? And imagine this force, forget about others, this force is also trying that this object can go like that, goes up. Is it clear? Which means that this is going to be anti-clockwise. Understood? Okay. The most tricky one is this 4. But don't worry. The 4, this is line of action. 4 is acting this way. Now, if you look at the line of action, this is 90 degrees from the pivot, and this is the perpendicular distance. So 4 into 40, and this is also trying that this goes this way. It's pulling it like that. That's why it is causing an anti-clockwise moment. This is why I added all anti-clockwise moments together. I added clockwise moments, and then resultant moment was, because anti-clockwise was 470, clockwise was 150. So resultant moment was 470 minus 150, 320 anti-clockwise. So this is how you find resultant moments. Okay. All right, that's pretty good. Now, on to what we were doing. So, again, it is very important. These questions will be very hard if you do not remember what I've just done today. Anyway, so the next thing I'm going to go is basically called torque of a couple, which is given by the symbol of torque is this T. And torque of a couple can be assumed to have an effect when. So there are certain conditions for this to work. First of all, two forces have the same magnitude. So when I talk about couple, it means it's talking about two forces. Okay. Then the other condition for this should be that they have opposite directions. All right. Then these two forces must have parallel line of actions. I'm going to explain what this means. And the fourth point is that they must act on the same body. Now, what I've written here, they can ask you this for the condition, and they will test you out for this as well. So you guys need to remember that. Now, with respect to this, I just want to tell you that suppose there's an object like this. Its center is here. This is the center. And torque of a couple means there are two forces, one force acting this way of equal magnitude, let's call this F, the other force acting this way of equal magnitude like this. Now you see, if this is the radius of the circle R, this would also be the radius of the circle. Now, the first condition is that there has to be two forces of equal magnitude, which you can see right now. They have opposite direction. This is going up, this is going down. Fine. The third thing is they must have parallel line of actions. So the line of action of this force is here and the other force is here. So they are parallel to each other, right? And then they must act on the same body. They are acting on the same body, as you can see. Now, the net effect of this is that because of this perpendicular distance, this force is causing a moment this way, which is anti-clockwise, and this force is causing a moment this way, which is anti-clockwise as well. Now, if I look at the moment of just one force, I can say it is force times the perpendicular distance. But then when I say torque of a couple, which means now it is the moment of two forces, which means F dot R plus F dot R is going to be the total moment acting on this. Do you guys agree? Now please understand this. If I add this together, it's going to give me a value of 2FR. Can I also write this as F times 2R? Would you mind? It's the same thing, right? If I write it this way, then you see 2R is the distance from one force to another force. Basically, that is R plus R, let's call this S. So if I say S is equal to 2R, I can replace it here, which means torque of a couple will be F times S. This is what you guys need to remember. Now, what does that mean? Okay, so let me just explain this here. So when I say torque of a couple if F times S, it means that this is one of the forces and this is the distance, perpendicular distance between the two forces. Is it clear, everyone? Please look at it and let me know if you have a question here. Zirva, everything is clear? The second step. Okay. Yeah. Okay. See this. This force is, because this is the center, this force is producing a moment here. All right. So it is F times R. And it will turn it this way. Understood. This force, Asma, is also producing a moment this way. So it's going to turn it this way. So it is also F times R. In the same directions, we can add them, right? Do you agree? Now this is going to be 2FR. FR plus FR is 2FR. And I can also write it as F times 2R. Right? So now check this out. This distance from here to here is R. This distance is also R. So total distance between the forces is S. You agree? All right. Now, this means that S itself is equal to R plus R, which is 2R. So I can replace this 2R with S right here. So that means that actually to find the torque of a couple, you just need the magnitude of one force and the distance between two forces. It will give you the total torque of that couple. Get it? Right. Now, do not forget about the conditions that I've written, because these conditions basically dictate what you guys, how you can basically create a torque of a couple. And it's very easy, right? You guys are doing this for so long. If you drive a car, right? So those who drive the car steering basically looks, if it's mine, looks like something like this, right? Okay, wait. All right. Oh, right. So the steering, when you steer a car, you turn it somewhere. So you might notice that basically the turning effect takes place because when you're turning, you're basically applying a force downwards here. You're also applying the force upwards. That's how the whole steering wheel turns. Right? So that's also a torque of a couple. Anyway, the question is that it is not when it is not a couple. So suppose you have a body, two equal forces, one F, the other one like that is also F, but now they are parallel, are acting on the same body, but they're not opposite. So one will try to turn this way, the other will try to turn it this way. It is not going to turn at all. Then the other way, it cannot be a couple, is when suppose one force is equal magnitude like that, but then the other force is like this. It's in a completely different direction. It's not opposite. So this is not a couple. Then it would not be a couple if one force is acting this way and the other force is acting this way from the same point. It means they're not parallel. They don't have parallel line of action, so it will not turn again, which means this is not a couple at all. Okay? Any questions here? Please let me know. Caroline, Farina, Fatma?
No, sir, no question.
Okay. So now, whenever they will give you a sort of a question in MCQ, you will find these in abundance actually, these type of questions. So you should automatically remember these four conditions, and if some object or some diagram doesn't meet it, then you should not take it as a couple. Anyway, then let's look at the next thing. So I'm going to give you guys a question. If you guys do that, I will be very happy. So let's see. So they have given you a body like this. Within this body, they've applied a force. Uh-oh. There's a force acting like this. This force is called F1. And then this is the center of the object, C. This distance is R. Okay. And then there's another force acting on this side. Oh, on this side. And this is F2. And this distance is 1 over 4R, let's suppose. Okay. Now they say force F1 and F2 are equal in magnitude and opposite to each other. All right. Part A, suggest if the two forces produce a torque of a couple. So first question this, then the second one, let's write it here. Find the torque of a couple in terms of F2 and R. All right. Can you guys quickly do this, please? Let me know the answer, please.
For eighths, no,
Why?
because the force is the same magnitude, but the radius, which is the distance, is different. Therefore, that means that the moment or the torque produced will be different on the each side, so that it's not, it's not the same anti-clockwise as clockwise.
Okay. Who agrees with him? Who agrees that this is not a torque of a couple? Nobody? Everybody agrees? Now, Mohit, let me tell you why this is a torque of a couple. You see, you need to basically only have these, you need to basically cover up these four, I'd say, conditions. Okay. First of all, can you tell me if they're opposite to each other? Like if they have equal magnitude. Do they have equal
Yes.
magnitude? Check.
Mm,
Do they have opposite directions?
yeah.
Check. Do they act on the same body?
Yes.
Do they have parallel line of actions?
Yes.
So all the conditions are met. There is no condition that basically their distance from the center has to be same or not. There's no condition like that. Do you get it? Because in reality, we do not need that distance. What we need is the perpendicular distance between the two forces, which is this s. Do you get it?
And
And s could be anything. S could be half hour plus hour or a quarter hour plus hour, 3/4 per plus hour. But it should only meet these four conditions for it to be a torque of a couple. So this is indeed a torque of a couple. Do you get it?
eight.
Now, now that you guys know that this is a torque of a couple, can you please do the next part? It's good that you asked the question
Well,
because it's clear. Yes, yes, Imal.
is it F2 times 5 by 4R?
Yes, that is correct. That is correct. The reason why this is correct because our formula for torque of a couple is one of these forces times S. We want to write in terms of F2, so it doesn't matter. We can write F2. And the distance between two forces is 1/4 R plus R. So that's going to be basically 5 by 4 R. So total torque of a couple will be 5 by 4 F2 times R. Is it clear? Anything that you guys did not understand, please let me know. Okay. Everything's clear. So I guess then I will see you people in tomorrow's class. Let's finish this chapter up.